Dr. Vama, you can start a session. And one more thing that you can in between, whenever you get the message for participants to get admitted, you may please admit them for
Okay,
the session.
sir.
I will not be there for the whole
Okay.
session. Thank you. Thank you. Bye.
Sir, I have a query.
Please.
Okay, sir, when I tried to
Please.
download Ilvis software, the site wasn't working. So how can I download that software?
You please check the link that you are, because everybody else has downloaded that software. So, and even somebody complained, but I checked it myself. I found that link was working. So maybe you were not checking the current link. Otherwise, we can you can send me a message in my WhatsApp. I can try to see if I can send you the correct link. Okay.
Okay, sir. Okay, sir. Thank you, sir.
Thank you.
So, student.
Sir, do we need to submit?
Hello. Sir, thank you very much for giving me this opportunity. For delivering today lecture. So, students, my name is Omar Verma, and I am working in the School of Sciences, Indira Gandhi National Open University, UP. So, as a part of the coaching sessions of programs like postgraduate certificate in geoinformatics, postgraduate diploma in informatics, and MSc in geoinformatics. So today we'll talk about the basic of mapping. Am I audible?
Voice is breaking, not
Yes,
proper.
sir.
Okay. So today I will discuss about the basics of mapping. It's a part of the first semester course. And it is a first course of first semester that is on introduction to geoinformatics. So in geoinformatics, maps and pings play an important role. So before studying the satellite images and aerial photographs, it is very important for us to have a sound knowledge of maps and its aspects. So
Nothing is audible.
Dr. Oka Verma, please unmute your mic.
So hence, the mapping is a very interesting part of this course, and for understanding the satellite images and photographs, or sound knowledge of mapping is very important. So the first unit, which is on the datums, map projections, and coordinates. In this unit, what is datum, different types of map projections and coordinate systems, they are discussed. So it is very important for us to have the knowledge of some basic aspect of the Earth, how we can represent the surface of Earth, making various observation. For example, if we want the height of any the Earth surface, some kind of the plane or the datums or a surface is required, which we consider the height of the object is zero, and from that base point we can be able to measure the height of any objects. So far, determine this such surface, the scientist has developed various given various concepts. For example,
Sir, we are having interrupted audio. Sir, you may try to be closer to your mic.
various concepts under the term is the and so that So am I audible?
Yes, now
Okay.
you
Yes.
are.
So there are so many models which are used to represent the surface of the Earth. So among them, the one is geoid. The geoid is an approximated figure of the Earth, and it is the basically it is a sea level equipotential surface, and in which the surface is remained equivalent to the gravitational potentials of the Earth. So the other models, we have the ellipsoid models, and this is based on the mathematical calculations. And here we can represent the Earth's surface as shown in this figure. And if we see these figures, so this is the geoid, and it is, and this plane is very close to the equipotential gravity of the Earth. And here, this is the ellipsoid, and this yellow one is the,
सर दिस बुक कोड क्या है इसका?
इसका कोड है MGY102, MGY101. In this figure, here you can see this is a line which is irregular in shape. It represents a plane which is known as the geoid, and it coincides with the mean sea level of the Earth. And here there is another line which is spherical in shape, and it is known as the reference ellipsoid. And this line is drawn based on the mathematical observation, and the another, which is thin line, irregular in shape, it is drawn based on the gravity of the Earth. So these surfaces are used to measure the height of the object from the particular datums or reference plane. And how we can measure, this is interesting part. So there is a term which is known as mean sea level. So how we determine the mean sea level? So actually mean sea level, it represents the average of low tide sea level and high tide sea levels. If we have high tide sea level, the value of high tide sea levels, and the value of the low tide sea levels, and after subtracting these two values, we get a mean average value, and that value is known as the mean sea levels. So mean sea level is nothing but it represent an average surface or the level of the high tide and the low tide. So this is the levels where we can measure the height of any object, for example, a mountains or a hill, from this level. So the another is the coordinate system. So coordinate system is very important, and it is very interesting. It is very important because the coordinates, which consist of latitude and longitudes, they are used to to represent the location of any object on the Earth's surface. So our Earth, they have numerous or several numbers of the longitude and latitude. And these latitudes and longitudes, which consist as these geographical coordinates, are the imaginary lines which cover the entire or the whole Earth surface. So we have 180-degree total latitude lines. The latitudes are those lines, those imaginary lines which are running from west to east, and they are parallel to each other. As a result, they are also known as parallel. So the latitude, they never cuts each other. So there is a 0-degree latitude, which is known as equator, and it divides the Earth into two hemispheres. This south one is known as southern hemisphere, and north one is known as northern hemisphere. In the southern hemisphere, we have 90-degree latitude, which starts from 0-degree from equator and runs to the 90-degree to the South Pole in case of the southern hemisphere, and in the northern hemisphere, it starts from the equator 0-degree to North Pole 90-degree. And similarly, the longitudes, we have 360-degree total longitude, and there is 0-degree longitude, which is known as prime meridians, and it divides the hemisphere into the Earth into two hemispheres. The one is the western hemisphere and other is the eastern hemisphere, and we have 0 to 180-degree longitude in western side and 0 to 180-degree longitude to the eastern sides. So this imaginary system of latitude and longitudes is very important to locate any object on the surface of the Earth, and also to set the time zone for a particular country. Similarly, we have the spatial, the Cartesian coordinate system. So the map projections, they are very important for us to represent a particular surface of the globe or Earth on a piece of paper or a plane surface. So for understanding the map projection, it is very important to have the knowledge of the geoid, ellipsoid, and coordinate system. So map projection is a systematic transformation that allows the orderly represents of the Earth's spherical graticules on a flat surface, or in another sense, it is a transformation of the geographic coordinates. The geographic coordinates, they includes the latitude and longitude into the coordinations, that is XY coordinate plane of the map, the sheet. Basically, the map projections, they are used to represent the three-dimensional objects of the Earth's surface in a two-dimensional format. So we have the several kind of the map projections. So there are some steps which are used to create the map projections, which are given here. So we have a various type of map projection. The number one is Mercator map projections. Then we have the transverse Mercator projection. Then universal transverse Mercator map projection. So this is a very important map projection, and this map projection is used globally. Then we have the Lambert conformal conical projection. Then we have the polyconic projection. So here, this is the Mercator map projections, and it is introduced by the Mercator in 1569. So in Mercator map projection, this scale is true along the equator, that is 0° latitude. And this map projection is used to represent the feature both on the eastern and the northern and southern hemisphere from 0° to 80° to the north and south. Then this map projection is modified version. Its modified version is known as the transverse Mercator, the map projection, and here there's the universally accepted version, which is known as universal transverse Mercator map projection. And this map projections, it extends around the world from 84° north of the equator. जो यूनिवर्सल ट्रांसवर्स Mercator मैप प्रोजेक्शन है, इसको बहुत ज़्यादा इस्तेमाल किया जाता है, और इसका जो इम्पॉर्टेंट एस्पेक्ट ये है कि जो नॉर्थ हेमिस्फेयर है हमारा, it is almost covered by the land, and this map projection can be used to represent the area studied from 0° equator to 84° north in the northern hemisphere, and in the south it is used to represent 0° equator to 80° south. So what is special in the universal transverse Mercator projection? Its the importance is it extends or add 4° more in the northern hemisphere from 80° to 84°. So if we represent the feature of the earth by using the universal transverse Mercator map projection in the northern hemisphere, so without the distortions or without the much errors, we can represent the area 0° equator to 84° north in the northern hemisphere. So this is the one of the main characteristics feature of the universal transverse Mercator map projection. Here you can see this is the most of the area. This is 0°. It is known as the equator, and the northern continents, they almost covered in the 84°. आप देखेंगे अगर तो ये 0° इक्वेटर चल रहा है हमारा, ओके, एंड इस इक्वेटर से हम 2 वर्ड्स नॉर्थ जाएं तो 84 डिग्री में ही जितना भी लैंड सरफेस है they are almost covered by this projection. So that is why it is universally accepted map projection. And towards the south, it is used to represent the area up to the 80 degree. Now, I will discuss about the another unit, that is understandings map. So in this unit, the many aspects related to the understanding of the map. For example, what is a map, its types, map scale, map elements, then color composition of the maps, the visual aspects of maps, comparison of different map layouts, they are all discussed in this unit. So first, how we can define a map. So map basically we study the maps under a branch of science which is known as cartography. So cartography can be defined as an art and science of designing, constructing, and producing map. So the science which is deal with the designing, constructing, producing map, it's known as the cartography. So the Indian Space Research Organization has launched the 4 satellites which they named as Cartosat. So their names, Cartosat, it indicates that the dot which these satellites are producing, they are mainly used for the cartography purposes, for map making or related aspects. So a map is nothing, what it is the graphical 2-dimension representation of all part of its features on the plane surface drawn to a specific scale. So here it is important to give attention on the specific scale. Why this scale is important? You see, our Earth is cover a very large area, and we don't have such a piece of paper where we can represent the Earth in its actual shape. And suppose if we have such piece of paper where we can represent surface in actual shape, so then how we can spread or keep such a piece of paper in a particular place. So to overcome these difficulties, the cartographer, they use the word scale. So in scale, we can show the part of the Earth by reducing the size in a particular piece of paper with the help of scale. So how we can scale? So before defining the scale, let's have the look of the types of the maps. So scale is nothing but it represents the relationship between the distance on the map and distance on the ground. If we have the knowledge about the scale, so then with the help of the maps, we can determine the distance between any 2 points. Of the maps, and maps, they are defined based on the scale and based on the functions. So based on the scale, we can define as map, or we can divide the map as large scale maps and small scale maps. So large scale maps like cadastral maps, topographical maps. The important aspects of these maps that they cover less area, but the amount of information we get from these maps is huge. So we can get the finer information from the large scale maps. So for planning, for tone planning or any or other related the application like the for making the engineering projects or the for constructing roads, dams, or other the other things that we need the large scale maps. The another maps, they are small scale maps. So in these small scale maps, the examples are given here, the wall maps. So these maps cover large areas. They can cover a country, they can cover the whole globe. What the informations they show, they are very coarse. So we get less informations, but the coverage of the area is very large. So based on the functions, we have the various maps, and these maps, you can say these are thematics map. They are based on a particular theme. For example, the relief maps, these maps show the relief of a particular area. Then we have the geological maps. They shows the different rock types of a particular area. Then we have the climatic maps. They shows the different climatic zone of a particular area or country. Then we have weather maps, different types of the soil that can be shown in the soil map. We have the natural vegetational maps, then we have the astronomical maps. These are the physical and natural maps. The physical natural maps, they shows the physical features or the information related to the physical aspect of the earth. And then we have the cultural maps. The cultural maps, they shows the features which are man-made or made by the man, and these maps can be political maps. We show the political boundaries. Then we have the population map, show the population density. Then economics map shows the various economic zone of the country. Then we have transportation maps, which shows the railway lines, roads, or other routes. Then we have the agricultural maps, industrial maps, and historical maps. So these are the main types of the maps based on the scale and function. Now I will discuss about the map scale. So for representing a part or the whole surface of the earth, we need scale, because a scale allows to reduce the whole or a portion of the earth to a size that is convenient and handy to represent the portion to be shown, as well as has scientific and logical values. So this is the reason that all maps are scaled down so that they fit on the available paper. So how we can define the scale? So a map scale, it represents the relationships between the distance on a map and distance on a ground. So map scale can also be expressed as a ratio of distance between any 2 points on a map and their corresponding distance between the same 2 points on the ground. So as a result, the map scale is a method which is used for expressing the relationship between map distance and ground distance. So this is the reason understanding the map scale is very important to study and represent the features on the map. So there are various methods of scale representations. The three methods are very important. Number one is statement of scale. So next time, whenever you will use the map, please note down its scale. It is given at the bottom of the map. So there are three main ways to represent a map scale. Number one is statement of scale. So statement of scale, it is considered as the simplest method of scale representation. And in this method, the scale of a map is expressed in a written statement like 1 centimeter equals to 10 kilometers. Its interpretation can be made as that 1 centimeter on a map is representing 10 kilometers of the corresponding distance on the ground. So if you will get this type of a scale on a map, then you can say that this scale is the statement of scale. Then we have the graphical scale. So this is another method of expressing the relationship between a distance on a map and the corresponding distance on the ground. And here the graphical scale, it is appeared like this here. So this is the graphical scale, and it has some divisions. On the left side, there is the zones divided into sub-zones, and this division is known as the string. We have 1 to 3 kilometers, and this division is known as the primary division. Then we have the another type, the scalar representation, which is known as representative fractions, and it is given as that is the RF is equal to 1 divided by 1000, for example. And in this case, the unit for both the numerators and denominator should be same. So if we consider that, let's take the unit an inch, then 1 inch, and you should also write for the 1000 should represent the 1000 in inch. So it means the 1 inch or 1 centimeter distance on the map is equal to 1000 inches or centimeters on the ground. So this is the method of representing the scale is known as the representative fractions. So there are the three types of the the methods which are used to represent the scale. The number one is statement, the statement of the scale, and number two is the graphical scale, and number third is the representative fractions. Now, there are some map elements which we can see in the maps. So these map elements, they are used to communicate the various informations that a map contains. And let us study the various map element. The number one map element is title. So title is a very important feature of map, and a title of map will tell us what it is for. For example, in this case, here the title is Map of India. So it shows that this is a map of India. So generally, the title should be simple and clearly indicate its purpose. The title is usually displayed on the top of the map to provide a clear indications of the thematics and geographic region displaced by the map. So here in this map, you can see here, this is the title, Map of India, and these are the border lines. We have the north arrow. The outer line is known as the water line. Here, the inner line is known as a neat line. So we have the legend here. Then we have the scale. This is the graphical scale. Here we have the map projection. This is the polyconic projection and survey of India. So it means this map is prepared using the polyconic map projection, and it is prepared by the survey of India. And the complete figure be showing the map of India. It is known as the map or figure. Then we have the legend. Legend is the guide that lists symbols and colors used on a map to represent different geographic features. The scale provides important information regarding the linear aspects of the map to the users. And scale can be shown as a statement of scale, graphical scale, or the representative fraction, that is RF. For determine the direction of the map, we have the north arrow. If we have the north arrow, the other direction, that is south, west, east, can be determined. Then we have the credits. Credits include the name of the cartographer and the organization responsible for map making. So credit also indicate the accuracy of the map, date of the publication, revision, and other explanatory materials. The credit should be written in small readable text, preferably as a footnote to the map. Then we have the system. So that is a map should have the coordinate system, that is latitude and longitude. Of latitude and longitude, we can determine the location of the map. Then we have the border line and neat lines. So whenever you will get the opportunity to see the map in the future, you see it very clearly and observe that you will observe that a map contains numerous colors, and these colors are used for representing the specific features. Blue color is used to represent the water bodies like lakes, dams, river, drainage, reservoir, and oceans. Then there is a black color. Black color is used to represent the buildings, roads, railway, highway, wages, place names, water surveyed, spot elevation, and all levels. Then we have the white color there. It shows the areas that are mostly clear of forest, field, plains, sand flats. Then we have the green colors. The green color is usually used to represent the covered by forest, books, jungles, parks, golf courses, forests. Then we have the maroon colors, and it is used to represent the contour lines. And finally, we have the red colors. So red colors, they are used to represent the cultural features such as the human habitats, villages, cities, main roads, and boundaries. So if you have the knowledge of the colors, then you can easily interpret the features, the features, whether they are cultural or physical, present in a map. Part C. So in a map, there are three features mainly shown. Now, number one is point features, line features, and polygon features. So here, a map, there are three types of features are shown. Number one is the point features. Here you can see this is a point feature. The point feature can be name of a place. We have line feature linear features, and it can be river or we have area features, and the point features that has the boundaries, closed boundaries, and the text can also be considered as a feature, and it can be represented in the written words. So here, if we want to represent some themes in a map, so it is very important to select a balanced layout for representing the themes in a map. So here different the particular information of map is the unbalanced layout. Here these two are the features shown the right margins are not properly arranged. So it can be considered unbalanced layout and cannot be used to represent particular theme. And here in another layout, it is an unbalanced. So the second layout is also unbalanced because the features shown on the right margin and left margin, they are not properly arranged. So this layout is can also not be used for representing the themes. And here the third one is also unbalanced layout. Here the things are not properly arranged. And in the fourth, the last one, you can say that the features are properly arranged, and that is why it is known as the balanced layout. So this type of layout can be considered or can be used for representing the various features in a map. Or you can design your own layout in a best way to represent the features so that it gives the best display of the feature which we want to show. So here, take this example, we want to show the map of India, and here the figure is not properly displayed in the layout which is given in the A figure, and similarly here the layout is not proper, and in the third figure, that is in C, the figure is not properly arranged, and in this case the figure in D, the figure is the map of India is properly arranged and it is considered as a balanced layout. Sorry for inconvenience. Actually, I got a urgent phone call. So here, this is D. It appears a better balanced figures. So we have in this unit, I have discussed their types, skills, point, line, and area features, which are usually shown in the map, and how we can design or make a balanced layout for representing the thematic information which we want to display in a particular map. So the another unit, it is on the basic of map reading. And in this unit, what are topographical maps, their numbering system, international and national. Then how we can read the topographical map, different types of the topographical maps, a survey of India, and the map projection parameters, they are discussed in this unit. So in the last 2 units, we study the datums, map projections, map elements, coordinate systems, scale, symbols, colors, map features, the elements of the maps. So all these things are very important for studying the map or getting the useful information from the map. So generally the map we see, they are the two-dimensional maps because they represent the two-dimension features on the maps. These two dimensions are the length and width. If you have the ball map or the road map, so in those maps you can get the idea of the length and width of a particular feature. What if you want to know the height of a features? So how we can get? देखिए, अगर आप एक नॉर्मल मैप को देखते हैं तो आपको सिर्फ 2 चीजों की इंफॉर्मेशन मिलेगी कि कोई फीचर है, कोई ऑब्जेक्ट उसमें दिया गया, चाहे कोई रिवर है और कोई पहाड़ी है, तो आपको उसकी लेंथ और विड्थ जो है वो आपको मिल सकती है. इफ वी वांट टू नो द एलिवेशन, अगर आपको जानना चाहते हैं कि उसकी हाइट कितनी है, यू विल नॉट गेट फ्रॉम दोज मैप. सो कार्टोग्राफर ने फिर समझा कि हमें हाइट दिखाना है तो हम किस मैप से दिखा सकते हैं. So then they designed the other type of the map, a new type of the map, which is known as topographical map. So topographical map, actually the topographical maps, they are the two-dimensional map, but they represent the earth, 3 dimensions of the earth. So in topographical map, you will get the information of the length, width, and height. So representing the height in the map makes the topographical maps differ from the other maps. So that is why they are known as the topographical maps, because it represents the topography of a particular area. What is topography? Topography is nothing but is the height above the mean sea level. It is known as topography. And if we are measuring the depth below the mean sea level, then it is known as the bathymetry. So if you have the topographical map, then it indicates that this map represents the height or relief of the earth above the mean sea level. So in topographical maps, we use the contour to represent the third dimension, that is the elevation. What are the contours? Contours are nothing but they are like the imaginary lines, like the latitude and coordinate, the latitude and longitudes. What the contours, they are joining all the points of the equal height above the mean sea level. So this is the definition of the contours, and the contours are used to represent the height above the mean sea level. So this is the numbering system of the India for identifying the particular map. If you know the value of the, this is the latitude and longitude, then by plotting the value of latitude and longitude in the index sheet of Survey of India, you can be able to identify the number of any topographical map of a particular area. But provided that if you want to know the number of topographical map, so you or we should have the values of the coordinates, that is latitude and longitude of that area. So earlier, the Survey of India prepared the topographical map in polyconic, using the polyconic map projections. And after 2005, so India adopted the new map series, which is known as Open Map series, and the Survey of India has given new numbering system for the maps which the Survey of India prepared under its Open Map series, and the number like this. And in this here, in these figures, these are the numbering system for the maps belonging to the Open Map series, and detail is given here. And if you have the value of the latitude and longitude, then you can be able to determine the number of particular topographical map. And now the topographical map, they are available at different scale. For example, the 1 million map, the topographical map, it is available at scale of 1:1 million. And we have 1 degree map. It covers the 1 degree, and its scale is 1:250,000. Then we have the another map, the 1:50,000 scale. Survey of India also preparing the map with the scale 1:10,000 scale, and these maps gives more informations and useful for the town planners, engineers, administrators. So now, if you see any topographical map, that map contains some symbols and colors. These symbols and colors are used to represent various physical and cultural features. The knowledge of these symbols and colors is very important to easily study the features present in the maps. For examples, these type of the symbols are used to represent the roads, metal roads. So here we can see the various types of the symbols, and these symbols represent the various type of the informations. So these are the symbols of the those maps which are prepared on the open map series of Survey of India. In India, the Survey of India, it has its headquarters at Dehradun, and this is the Government of India agencies which is responsible for making the maps for India. Now we have marginal information which is available in the Survey of India topographical maps, and this information includes here, it is the topographical map of a region, and at the margin you can see the various types of the information. For example, the name of the district to which this map belongs, and then area of surveyed, the name of state or states covering by the map. Then we have the nature of scale. Then we have the topographical map number related to the latitude and longitude. And at the bottom of the map, you will get the various information. For example, legend are shown here. Then administrative log is shown here. The name of the preparing and publishing agency is there. Then contour interval, what is index to sheet. Then we have the information related to the information related to the scale. So this type of information you will get while studying the margin of the topographical map. So whenever you will start to study or interpret the topographical map, please study its margin, see its margin very carefully, and observe the information that they represent. As I already said that the topographical maps, there are various types. Then we have the million maps, and its scale is 1:1000. This map has 4° into 4° latitudinal and longitudinal coverage. So each map under the million map type is given a serial number or topographical map number, for example 39, 40, 41. So if we see the index map of the numbering system prepared by the Survey of India, then you will get the clear understanding of the million map. Then we have the degree map. So each million map is divided into 16 equal parts, and these parts are numbered as A, B, C up to P. And each map has 1° latitudinal and longitudinal coverage. Therefore, they are called as degree maps. So 1 degree map covers 11,140 square kilometer area, and its scale is 1:250,000. So degree maps are extremely useful for journal planning. And here each map is numbered as 58A, 58B, 58C. So 58 represent the million maps, and A, B, C up to P, they represent the each degree of 1 million map, which come under the 58 million map. Then we have the quarter degree map, scale ratio 50,000. So in this case, each degree map is again divided into 16 equal parts, and each part has coverage 15 minutes to 15 minutes of latitude, and these maps approximately 700 square meter of total area in each map. So these maps are prepared at a scale, as I already said, 1:50,000, and they are numbered as 58A divided by 1. So 58A, it is the 58A, it is the degree, it represents the degree map, and by 1 it represents the quarter degree coverage of the map. So these are general purpose map and are used for the administrators, planner, and engineers. These are the most popular maps for all activities of the government. Now we have the map with topographical maps with 1:25,000 scale. Here, each quarter degree map is further subdivided into 4 equal parts, in which each part has 7 minutes 30 seconds into 7 minutes 30 seconds of latitudinal and longitudinal extent, and each part of degree map covers 175 square meter area. These map numbered as 58 by 1 divided by northwest, similar northeast, southeast, and southwest part of the quarter degree map. These are more detailed map and widely used for planning and development purpose by the administrator and town planners. So based on the scale, we can use the map for a particular purpose. So the idea of the scale, or understanding of the scale, is very important to select a particular map for our own study. So here you can see this map, millionth map with scale 1:250,000, and this is here the coverage of the area is quite good, quite large, and here this is the quarter degree map, and it is 1:50,000, and it covers less area as compared to the million map. And here this is the map 1:25,000 scale, and it shows small area, but the amount of information is quite large. So now I will discuss how to extract the information related to the physical features and cultural features from a topographical map, and It is a part of unit number 13, which deals with interpreting Survey of India topographical maps. SOI, it stands for Survey of India. Topographical maps. So I already informed you that in topographical maps, we will get the 3 dimension of the earth features, and these dimensions are height, width, and relief of a particular features. So you also know that the topographical maps are of various types: large scale map that more than 1:25,000 scale. Then we have medium scale map that is ranging from 1,025,000 scale to 1:250,000 scale. We have small scale map less than 1:250,000 to then we have very small scale maps. So this division of the maps from larger to very small scale, it depends upon the scale of the map. So based on the scale of maps, we can call the large scale map. The large scale map cover less area but gives more information. And on the other hand, the very small scale map, they cover larger area, but they give very less information. So a topographical map mainly represent the 2 type of the informations. The number 1 is physical features. So physical features, they include the relief features. The relief features are hills, valleys, slopes, depressions, coastline, and gullies. Then we have hydrographic features, that is lakes, ponds, reservoirs, rivers, streams, and spams. Then we have the vegetation. Vegetation may be forest, wooded, cleared area, orchards, and plantation. So all these type of informations or features, they come under the physical features. And then we have the man-made or cultural features. These features includes roads, railway, airport, buildings, rural and urban settlements, name of places, geographic feature, administrative boundaries, state and international borders. They are the parts of the man-made features. So topographic symbols, maps, and colors, they are used to represent the various features on the map. So now you are aware that the topographical maps, they represent the physical and cultural or man-made features. So how we can interpret a particular map accurately? So before starting to interpret any topographical map, the common understanding of the contour arrangement, the colors, symbols, present is very important for accurately extract the information a topographical map is representing. So we know that the surface of the earth is not uniform, as it is made up of several physical or relief features like mountains, hills, plateaus, plain, rivers, lakes. The relief features on topographical map are represented by contours. And you know that contours are the imaginary lines which are connecting the points of equal heights above the mean sea levels. So therefore, or arrangement of contours on a topographical map is very useful to determine the nature of the relief features. For example, if there is either no contour or one or two contour lines crossing the map, this arrangement clearly indicates a plain area. Whereas a mountain area is marked by the presence of several contour lines. So if on the ground, if you have the variation in the height, so then there are chances that you will get numerous contour lines because of the variations. If you don't have the variations, the ground is plain, then you will not get much variation in the plain area. So this is very important. Information related to the contours we should keep in our mind while interpreting the relief features in a topographical map. So how we can extract the information or various type of the slope or landforms with the help of the contour lines. So we know that different arrangement of the contour lines represents different relief features. So how different types of slopes and landform are represented by the contours, we will now study. So contour representation for different types of the slope. So you are aware that we have the gentle slope, we have the steep slope, we have the convex slope, we have the concave slope, we have the uniform slope, we have the regular slope, we have the irregular slopes. So how we can identify the different type of slopes in our topographical map? So number one is gentle slope. In gentle slope, the contour lines are widely spaced. So gentle slopes, if you have a map and the contour lines are widely spaced, okay, so you can get the information that in this area the slope is gentle. And now another type of slope which is known as steep slope. In this case, the contour lines are closely spaced. Here in this figure, on the right side, here you can see this steep slope and its representation on the contour on the topographical map. It looks like this. So here at the right side, you can see that contours are closely spaced and it represents the steep slope in the ground. And on the left side, the distance of the contour is quite wide. So on the ground, it represents the gentle slope. So this figure clearly shows that what type of the arrangement of the contour indicate what types of the slope. So now we have the convex slope and we have the concave slope. So in case of convex slope, contour lines are closely spaced. near the bottom of the slope than near the top. Here, this is the bottom of slope, and here the value is 100, and now this is top because the value is 700. Now the value is increasing from bottom to top. So here the contours are closely spaced, and here the contours are widely spaced. So this type of the arrangement indicate the convex slope, and in this case here you see that this is the bottom and slope are, and the contours are widely spaced, and here this is top, the contours are closely spaced, and this type of the arrangement indicates concave slope. Now we have uniform slope. In case of uniform slope, contour lines are evenly spaced. You will get evenly spaced contour line. For example, there is regular arrangement of the contours. So such type of the contours indicates a uniform slope. And irregular slope, the contours lines are unevenly distributed or spaced. And such type of the arrangement indicates irregular slope. Now the contours are used to represent different types of the landform. For example, ridge. A ridge is represented through elliptical arrangement of the contour lines, and the value of the contour decreases outward. And in depression, depression is represented by the closed hexure line contour lines. So hexures are defined as small vertical marks line inside the contour, pointing towards the region of lower elevations. So we have the spot height. Spot height are shown by number on topographical map. So in case of conical hills, the concentric contours spaced at a regular interval represent the conical lines. The conical hills. The contour lines from a closer near the upper part of the hills. So in case of the conical hills, the contour lines, they are closed near the upper parts. So in case of plateau, the contour lines representing plateau are closely spaced at the margin, and innermost contour line shows a wide gap between its two sides. So in the innermost, which represent the topmost part of the plateau because of its flat natures, so there is a wide gap between the two contour lines of its side. Here in this figure, you can see this is the depression, and inside there are small lines or dot. These are known as hexures. So here, this arrangement shows the depression. This is here, you can see ridge. This is the top of hill. Here x 270, it is the spot height. And these brown lines, they indicate the contours. Here the general slope, because the contours are widely spaced. And here you can see the steep slope because the contours are closely spaced. Here, this is, you can see the conical hill. This type of the arrangement of contours indicate conical hill. And here, this type of arrangement indicates the plateau. Because of the flat top of the plateau, so here you can get wide differences between the topmost contour. Contour arrangement to represent other landforms like U-shaped valley, and in this case, innermost contour line is characterized by having a lowest value and a wide gap between its two sides. The contour value increases uniformly outward. So in V-shaped valley, the innermost contour line is characterized by having a lowest value and a very small gap between its two sides. Contour value increase uniform outward. Here, this figure shows the representation of the contours. This is U-shaped valley, this is a V-shaped valley, this is a gorge. And in case of waterfall, contour lines merge into one another while crossing a river. Here, this type of arrangement, here the contour lines, they are merging each other, and this type of the arrangement indicate the presence of a waterfall. And cliff is a steep, very steep slope, and here you will see this type of the arrangement where the contour line running much closer to each other and merging with one another. Here in this figure, you can see this type of the arrangement, it indicates the presence of a cliff. So if you have the proper understanding of the arrangement of the contour lines, you can be able to identify the different types of the landforms and slopes of a particular area. So the other features of vegetation that we can extract the information from a topographical map. So in topographical maps, the natural vegetation is represented by the green color, and vegetation may be protected or reserved, and some other types may be identified with the help of the conventional symbols. So therefore, the proper understandings of the colors and symbols, they are very important for us to accurately identify or interpret the physical as well as cultural features present within the topographical map. So drainage system of an area is dependent on the slope, nature, and attitude of the topography. So drainage is clearly visible in the topographical map. So if we have the understanding of the slope, then we can able to determine the direction of the drainage. So drainage is studied according to its pattern, texture, density. And basically there are 6 types of drainage systems: dendritic, trails, parallel, radial, angular, and rectangular. Different types of the rivers, the tributary extent of the valley formed by them can also be determined from the topographical map. So in a topographical map, we can extract the information related to the various physical features, and these features are relief features. Relief features further divided into slope and landform. Then we have vegetation and drainage. So this type of information which we extract from the topographical map, or which is represented in topographical map, they constitute the physical features. Now, the cultural information or the man-made feature are also represented in the topographical maps, and these features comprise buildings, roads, settlements, dams, industries, railways, etc. So with the help of the conventional signs, colors, symbols, we can identify different types of the cultural features. And the cultural features are land use, means of transport and communications, and different types of the settlements. So lastly, if we want to study the topographical map, so we need a good understanding of the conventional signs, symbols, and legends. so that we can accurately identify or interpret the features present in the topographical maps. So if we want to interpret or study the topographical map, so we should start with first with the marginal information. So marginal information, this includes topographical map number, name of the place, year of publication, latitude, longitude, extent, scale, district covered by the maps, contour interval given in the map, and grid references. These are the information first we should note down. And then we study physiographic information. So physiographic information means which is related to the physical features. And the physical features, there are three types of physical features. Relief, it includes the identification of general topography of the area, such as mountains, hill, plateaus, plain, valleys, and their height, depth, nature of slope. So these type of information you can extract from the topographical maps. So for extracting this information, we should need a very good understanding of the arrangement of the contours. Then drainage, it includes the important rivers and their tributaries. Then vegetation, it includes the information related to the natural vegetations and its various types. Then we have the cultural informations. The following cultural information with the help of the symbols and colors and other legends, we can extract the information related to land use. It includes the arable land, wasteland, industrial, public land, and occupation. Then transports and communications. These include the national, state, district boundaries, metalled, unmetalled roads, airport, railway lines, post office, and other communication lines. And finally, the settlements. The settlements are various types, rural and urban. So these type of the information we can extract from the topographical map. So here we have given an example of a part of a topographical map with the interpretation. And you can select any topographical map of any area and with the help of the knowledge of contour arrangement, color, symbol, and other legends, you can try to interpret any topographical map at your own. So learners, today I discussed the basic of mappings, and in this session, I discuss various aspects of basic of mapping like the geoid, which is a reference plane used for measuring the height of the object above the mean sea level, and this geoid coincides with the mean sea level. Sorry. And then we discussed about the various type of the map projections, and importance of universal transverse Mercator map projections. Then we discussed the various types of the maps, map scale, and spherical coordinates, topographical maps, numbering system of topographical maps, and the physical and cultural features of the topographical maps, and how we can interpret or extract the information by using the conventional sign, symbol, and legend from the topographical maps. I hope you enjoy this session. So if you have any question, please. So student, if you have any questions, please let me know.